Mars, our cosmic neighbor. More spacecraft have traveled to Mars than any other planet. One day, humans will visit as well.
Humans should go to Mars, and we should do it quickly.
This rocky planet could almost be home.
Mars is very different than Earth, but in many ways, it's like a long-lost brother.
Yet Mars is an alien world.
Looking at Mars gives us some disturbing lessons about the future of our own planet.
What lies ahead for the first human astronauts to set foot on Mars? To find out, we will strip the red planet. We'll peel open its dusty surface and dive deep into its alien underworld, revealing the secrets that await the first human explorers on Mars. Mars, the fourth planet from the Sun. It sits 142 million miles from Earth. The average temperature is minus 80 degrees Fahrenheit. Today, scientists are racing to reach the red planet. 4 new missions are preparing to study Mars's atmosphere, geology, and weather systems in more detail than ever before. The ultimate goal, to land the first human astronauts on Mars.
Eventually, humans have to leave planet Earth. Mars is our first step outward.
I think that's going to be the key to our own survival, is going there and living on this planet. And we'll be able to explore the rest of the solar system from there.
Sending humans to Mars is really the next great challenge. We will get there, it's just a matter of when.
Mars may be one of our closest planets, but it is also home to some of the greatest unsolved mysteries in the solar system. Hidden inside, a frozen world may hold the key to Martian life. Vast canyons that would stretch from New York to LA scar the surface. Violent dust storms engulf the planet, while some of the tallest volcanoes in the solar system rise up from its plains. These supervolcanoes hide an alien underworld. Mars is a tantalizing destination for human exploration.
When we first got to Mars, it just looked like a cold, dry, dead planet. But the more we study it, the more we learn that it's actually dynamic, alive.
Before NASA launches a manned mission, they must confirm that Mars is habitable for humans. So they've sent a scouting party. The Mars Curiosity rover. Curiosity touched down in August 2012. It has roamed the Martian surface for more than 2 years. This 1-ton robot is the size of an SUV. It uses its high-resolution cameras and scientific instruments to uncover the secrets of Mars. Here on Earth, at NASA's Jet Propulsion Laboratory, Chris Roumeliotis is one of Curiosity's drivers. Chris can't make mistakes with $2.5 billion worth of gear. So he practices his skills on JPL's own little piece of the red planet, the Mars Yard.
We have all the rover drivers come up here and we test things to the limit so we see what happens. Every maneuver that has been done on Mars has essentially been tested in this Mars Yard.
Chris uses a full-size working model of Curiosity to perfect his maneuvers.
If you ever try to drive your car over this, not gonna happen. She can do it, no problem. We actively try to avoid rocks like this if we can, but look how gracefully she goes over that rock. Doesn't even drop.
Chris and his team have successfully driven Curiosity 5 miles across the Martian surface, thanks to practice here in the Mars yard. For humans to survive on Mars, the first thing Curiosity must find is water. Mars looks like a dry desert now, but features in the landscape suggest that Mars was once covered in liquid water. 3 layers of rocks lie beneath a top coating of red dust. The bottom rock layer is the oldest. It's an ancient lake bed that contains compressed clays and minerals once carried by water. Next is a salty layer, 1 mile deep. When the water evaporated, it left this salty residue behind, like a pan boiling dry. On top lies a cold, dry, dusty surface, worn down and smoothed over by billions of years of wind. Scientist Ashwin Vasavada leads the search for water on Mars.
We've been chasing evidence of liquid water on Mars for decades.
Curiosity's discoveries are astonishing.
One of the first things we found with Curiosity was rounded pebbles, about this size, rounded corners. You don't see that naturally without something grinding the rocks together. And the action of the liquid water flowing in a stream, grinding those rocks, created this ancient stream bed.
This dry stream bed proves that there was once liquid water on Mars.
We're really talking about water flowing maybe ankle to hip deep. So this is the first time we're really encountering, and holding in our hands, so to speak, this evidence of a habitable environment.
But could Mars support humans today? To find out, Ashwin needs to uncover what happened to all the water.
One of the big mysteries about Mars is that early in its history is where we find all this evidence for flowing water, lakes, maybe even an ocean. What happened on Mars to create this dry environment that we see today?
Scientists now believe that 4 billion years ago, oceans, lakes, and rivers covered the surface of Mars. Deep inside, Mars had a hot core of flowing metal, just like Earth. Mars's molten core created a magnetic field around the wet planet. This shielded its atmosphere from the sun's radiation. But eventually, the core cooled and stopped powering the magnetic field. Without protection, Mars's water evaporated into space. And Mars, the water world, became Mars, the desert. On the Martian surface, Curiosity looks for proof of how and when this happened.
The rocks may hold the secret to figuring out how Mars evolved from that life-sustaining state in its early history to where it is today. Curiosity is a rover, but it's also a geochemical laboratory. It's so big because we took these advanced chemical instruments to Mars inside the rover, and we feed those instruments with samples of rock and soil.
The rover now sits at the base of a 3-mile-high mountain, Mount Sharp. Its layers of rock were laid down over billions of years. They provide a record of the conditions on Mars at different points in its past.
We really hope that whole geologic record of Mars environmental history is preserved for us, and that just by driving through it, we'll be driving through 3-4 billion years of Mars history.
Come on, Ashwin.
Hey, good to see you.
Hey, yeah, so
Where are we driving?
Chris and Ashwin use a 3D landscape viewer to plan Curiosity's routes towards Mount Sharp.
here we're doing an arc to the left to avoid a rock.
They see what the rover sees on Mars, accurate to an inch.
Pretty gnarly terrain.
A lot of rocks.
Yeah. But she needs to go very slow today.
Yeah, right.
Because of
hazards.
the hazards, yeah.
Got it.
There's a 20-minute communication delay between Earth and Mars, so Chris can't drive Curiosity live. Instead, he sends a whole day of instructions to the rover at once.
Everything that's done in terms of operations has to go through this room. It is the center of the universe for us in our spacecraft.
At JPL's mission control, Chris hands over the list of commands.
How's it going? I think we're ready.
At the click of a button, Tomorrow's maneuvers head to Mars, guiding Curiosity on the next leg of her groundbreaking journey. NASA's missions prove that at some point, Mars was stripped of its water and atmosphere. But was all of Mars's water lost to space? Will future astronauts find any water left hidden beneath Mars's desert surface? And could they encounter Martians already living there? Within a generation, a human will set foot on Mars. The first visitors will experience a cold, barren terrain. Curiosity confirmed there was once water on Mars. Could human explorers still find water there today? Mars is so cold that its atmosphere freezes. Carbon dioxide snow covers the northern plains. 3 feet below this snowy crust lies an Earth-like secret, a massive reservoir of frozen water over a mile deep. These are Mars's ice caps. If these ice caps melted, they would cover the planet with over 60 feet of water. They contain 100 times the water in the Great Lakes. With this much water on the planet, could there also be life?
Water is a precursor for life itself. If there's water, there's a possibility of life. So maybe the Martians are not science fiction.
But Mars is so cold that water on its surface only exists as ice. For future human explorers to find life, they must look for liquid water that isn't frozen.
Life on Earth is very diverse. Not all life forms require oxygen. Not all life forms even require sunlight. But it seems that every single life form on Earth, no matter how diverse, requires liquid water.
Our best chance of finding liquid water on Mars may lie beneath the surface. Scientists believe that not all Mars's water escaped into space. Some became trapped beneath the landscape. Just below the Martian surface, the freezing ground locks the water ice in a layer called the cryosphere. The cryosphere stretches 6 miles down and could hold up to 50 times more water than the ice caps themselves. Below this layer, the ice disappears, but the rock holds patches of a chemical substance that could sustain life. Salt. Salt in the rock acts like antifreeze and melts the ice. It creates deposits of salty liquid water that could stretch up to 16 miles into the ground. Could Martian life survive in these extreme conditions? In Bulby, northern England, astrobiologist Sam Paler searches for the answer. He explores one of the most hostile environments on Earth, mines 3,500 feet below the surface.
We always thought life was this kind of thin film that surrounded the Earth. But actually, we found over the years that life extends much further than we thought into the deep subsurface, into the rock and into the actual fabric of the Earth.
The conditions in this working salt mine mirror the extreme environment beneath the surface of Mars.
Mars is covered in salt, and we believe those salts extend down into the deep subsurface. In order to understand whether anything can live in those deep salts on Mars, we need to come to a salty, deep environment here on Earth.
Sam collects a sample of salty water deep in the mine to determine whether any microbial life survives here.
This water has come out of the rock from the local geology around, and we're basically going to sample it in as sterile way as possible with sterile tubes and sterile equipment, so we don't infect it with any of our nasty human bacteria, and see what's living in there.
He analyzes the sample in the world's first permanent underground astrobiology lab that sits 2/3 of a mile down.
We've actually found lots of different types of organisms in here. They're all salt-loving, they all require salt, and we've actually been able to get some images of them. You can actually see the cells in the microscope slide. We're seeing something here that's lived 1.1 kilometers below the surface. It's grown, lived and evolved down here for many, many years.
Sam's work suggests that Martian life could be similar to these microbes, if it exists at all.
The really key to exploring Mars now is to get down into the subsurface. That's where our highest chances of finding any life would certainly be. We see life in so many environments on Earth that it's almost unimaginable that it isn't living somewhere else in the universe.
Water trapped deep inside the red planet may hold the key to Martian life. And Mars is not the only place in the solar system with hidden water reserves.
You might think that water is very rare in the cosmos, but actually, we're starting to find it everywhere we look. Water is on other planets, it's on other moons, there are even asteroids with lots of water.
This is Enceladus, a moon that orbits Saturn. Enceladus is one of the wettest places in the solar system. It's only 1/7 the size of our own moon, yet it holds a secret. Fountains of water and ice explode through its frozen surface and shoot more than 120 miles into the sky. These plumes erupt from a 6-mile ocean hidden deep below. But sitting almost 1 billion miles from Earth, humans won't be visiting this exotic water world anytime soon. For now, our best hope of coming face to face with water and life outside of our own planet is on Mars. But many dangers await the first astronauts. Global dust storms blanket the planet, while carbon dioxide explosions erupt from the surface. Mars has 24.5-hour days and light clouds that drift in the sky. It could almost be home. The red planet even has 4 seasons like our own, but its weather is nothing like Earth's.
On Earth, our seasons are caused by the tilt in our axis, and in fact, Mars has a similar tilt to its axis. So it has spring, summer, winter, fall, just like here. And at springtime, the winds begin to blow on Mars. There are little dust devils and tornadoes. There are global sandstorms. Mars comes to life in the spring.
Frozen carbon dioxide cakes the red planet's northern plains during winter. But in spring, it wakes from its slumber. Temperatures rocket and bring the Martian landscape to life. Beneath the frozen surface, the carbon dioxide warms up and turns into gas. The gas pressure builds, cracking the ice above. When the pressure gets too high, violent plumes of sand and dust burst 6 stories into the sky. The ice melts to reveal a vast expanse of sand dunes, the size of Texas. The North Polar Sand Sea. To protect humans on Mars, we need to prepare them for sudden weather extremes.
Mars has weather, so that's absolutely something that we need to know more about before we can send people there and expect them to survive.
Scientist Lori Fenton uses sand dunes to create a Martian weather forecast. She studies the landscape at the White Sands National Park in New Mexico.
There's dunes all over Mars, and we can use them to understand what the wind is doing and what it has been doing. In a sense, this whole dune field is a microcosm for Mars.
To predict the weather of the future on Mars, Lori must first understand the weather of the past.
Every time the wind moves the sand, it gets locked up in these dunes, and as the dune migrates on, it sort of traps its own history. And that's the secret, under our feet right here.
At White Sands, Lori inspects a trench cut into one of the dunes to find out more about the history of the climate here.
Each of these layers tells you something about the weather in this area. So each packet of layers might represent a season, for example. We would see similar features if we were to dig a trench on Mars.
Aerial photographs suggest that the sand dunes on Mars behave in the same way.
Mars is the most photographed planet other than Earth. Here's an image of a sand dune on Mars. This is the same kind of dune that we're looking at here at White Sands.
The North Polar Sand Sea is one of the largest fields of sand dunes in the solar system. The dunes are time capsules of Martian weather. Each layer is just a few inches thick, and like a photograph, captures a snapshot of the season's activities. A seam of fine particles indicates global dust storms. Next, a thick, coarse layer reveals an avalanche of sand from severe springtime winds, while a dark strip of ash suggests violent volcanic eruptions engulf the landscape. The first human astronauts must unlock these clues to predict future Martian weather. Digging a trench like this on the red planet will give them vital information.
We could use these layers to forecast weather on Mars by measuring how thick they are. That tells us how much sand has moved, and that gives us an idea of how strong the wind was, how long a wind event lasted. And then we could start to really understand weather patterns in many, many places on Mars.
Sand dunes are not the only phenomenon created by the Martian winds. During Mars's summer, strong winds also whip up one of the most common sights on the planet, dust devils. These giant tornadoes soar 12 miles high. They race across Mars's surface, creating worm-like tracks. Mars's unique geology causes these epic dust storms. This circular zone is Hellas Basin in Mars's southern hemisphere. It's the largest bowl of dust in the solar system. The basin is an impact crater, 4 miles deep. A thick layer of red dust cakes the surface. The summer sun heats the fine dust, and it lifts into the sky. These giant dust clouds block out the sun and plunge temperatures far below zero. In a Martian dust storm, there's nowhere to run.
When you consider the sizes of the dust storms on Mars, it's on a scale like nothing we've seen here on Earth. They are planet-wide.
We've seen this happen where Mars just kind of goes away. It just becomes this big fuzzy ball because it's enveloped in a global dust storm.
Even if the first explorers on Mars survive these lethal storms, they still face another deadly threat. Giant tremors, called Marsquakes, that rock the planet to its core. The first astronauts to visit Mars face bone-chilling temperatures and global dust storms. But their biggest challenge may not lie on the Martian surface. The threat could come from below. Planetary tremors, called Marsquakes.
We're now picking up more and more evidence that there are substantial tremors on Mars. In fact, the equivalent of something like a magnitude 7 earthquake here on Earth. That's substantial. These are not just little quakes, but large events.
Scientists used to think that Mars was a cold, dead rock. But these quakes suggest a secret lies below the surface of the red planet. They are evidence that Mars still has a molten core that is hotter and more fluid than they once thought. This hot interior could be what triggers the quakes on Mars.
lot of evidence that about 3.5 billion years ago, Mars effectively died. The plate tectonics stopped, everything cooled off, and Mars got very solid and dead in its core. But now we're beginning to reevaluate that. Maybe we're wrong. Maybe there is still some life left inside Mars.
To find the answer, scientists plan to give Mars its first physical in 4 billion years. Bruce Bannert leads the Martian medical team at NASA's Jet Propulsion Laboratory.
We're going to learn about the very deep interior of Mars, and in order to do that, we're going to sort of take its pulse to figure out what's going on inside, much as the doctor would do in his office.
This 800-pound robot is called InSight. When it lands on Mars, it will use a seismometer to accurately measure Marsquakes and discover where they are coming from.
The first thing we want to do on Mars is take its pulse. That really gives us a lot of information about the planet. And in order to do that, we have the seismometer, which is this orange object here. We're going to pick that up with this arm and grapple and place it on the surface.
This is a prototype of the lander that will travel to Mars. Bruce's team programs the robotic arm to place the seismometer in exactly the right spot without any damage.
Picking this up is going to be one of the real kind of heart stoppers. You know, we're going to give those commands and we're going to be sitting back on Earth, twiddling our thumbs until we get the confirmation back that it's down on the ground.
The team hopes that InSight will reveal exactly what causes the quakes on Mars. Here on Earth, the planet's crust is split into tectonic plates. As these plates move against each other, they cause earthquakes. Bruce thinks a very different geological process triggers Marsquakes.
On the Earth, we have lots of plates moving around all the time in a very dynamic fashion. Mars has one plate. It's just the whole crust is a single plate, and so there's nothing that actually moves around it because there's no cracks that allow that motion to take place.
A single slab of rock forms the crust of Mars. It extends 30 miles down into the planet, 5 miles deeper than the Earth's crust. The thick mantle layer below holds it in place. As Mars's hot core cools, it contracts. This draws the mantle inwards and pulls on the crust. Tension builds. The crust buckles and triggers a Marsquake. If all goes to plan, Bruce's seismometer will pinpoint the origin of the Marsquakes and help to confirm this theory.
I'm extremely nervous. I mean, any kind of a space mission is an enormously complicated endeavor, and there's millions and millions of things that have to go right in order to even get to Mars, much less, actually do the measurements.
InSight is scheduled to land on Mars in 2016. Only then will we discover what lies beneath the surface. Mars's unique crust also holds clues to other mysteries of the solar system.
Because of plate tectonics on the Earth, everything is in this grinding state of change, always moving around, melting down, building up. On Mars, however, things froze in time, billions of years ago. So you have an intact crust, an intact record of what the solar system was like a long time ago.
This unblemished record helps us understand one of the most puzzling features on the red planet: the two faces of Mars. One half of Mars is carved with mountains, valleys, and highlands. Craters from ancient impacts pockmark the landscape. Traveling over the planet, the craters and mountains start to disappear. Scientists believe that 3.9 billion years ago, an asteroid half the size of our moon slammed into Mars. It destroyed all the surface features and left behind a sea of molten rock. The rock hardened to form this massive flat plain, completely different from the jagged peaks on the other side. These are the two faces of Mars. Craters and mountains are not the only geological features preserved on the surface of Mars. The deserts on the Red Planet are also home to the 4 biggest volcanoes in the solar system, where giant lava chambers could hold the secret to human survival on Mars. Mars may be a small planet, but it has colossal geological features. This is Tharsis, a volcanic region covering 1/5 of the planet's surface. This range boasts the 4 highest peaks in the solar system. The tallest of them all, Olympus Mons. It covers a landmass the size of Arizona and soars 3 times taller than Mount Everest. This monster volcano holds an astounding secret. Under its skin lies an alien underworld, a rabbit warren of lava tubes and caves carved out by the searing magma that once spewed from the volcano's vents. The tubes stretch for hundreds of miles. Protected from the harsh surface, these lava tubes could shelter future visitors to the Red Planet.
If you're looking for a place to go on Mars, one interesting place for astronauts to explore might be near these lava tubes. Might give you some natural protection from radiation and meteorite hits and things that you're not going to be protected by because you don't have an atmosphere.
Volcanologist Scott Hughes searches for habitable Martian caves. His team investigates the Kings Bowl lava fields in Idaho because this volcanic region on Earth is remarkably similar to Tharsis on Mars.
It turns out that the features that we see here on the Snake River Plain are represented on Mars. If we understand how fissures and pits work on Earth, we're getting a much better idea of how we can explore them and what we need to explore them on Mars.
Scott knows from aerial photographs that lava flows like this cover the surface of Mars.
Yeah, you see this outflow channel there, and there's one here, and there's one over here. These are like lava channels that we see around volcanoes on Earth.
Here in Idaho, Scott's team maps out the rock patterns on the surface to identify telltale signs of lava tubes below.
Could they have made this thing any heavier?
They use special laser scanning technology called LiDAR to create a 3D model with millimeter precision.
LiDAR is a way to use little laser pulses to be able to capture the topography and the dimensions of the field that we're in, of the geologic features.
Mapping these volcanic features on Earth will help guide them towards the hidden lava tubes on Mars.
For some of us, this is the closest we're ever going to get to Mars. So we got to do our best here to understand it so that when the next generation of astronauts is able to make their own footprints on Mars, we have as best an understanding of where they're going in those landing sites as possible.
Lava tubes not only offer radiation protection for future astronauts, they could also contain precious metals and minerals for a Mars colony. Around 200 million years ago, magma from deep within the planet rose to the surface through volcanic vents. As the lava flow cooled, tunnels formed. Deep below lies a layer of minerals and precious metals. Mars's lava tubes form the perfect mine shafts for future prospectors to access these vital resources.
Once we get a good handle on these internal processes, we can have a better idea about where we can explore for the resources needed to maintain a civilization.
Where did Mars's ancient volcanic activity come from? We find evidence of past volcanism all over the solar system. This activity began 4 billion years ago. when asteroids and comets bombarded the early planets.
The bombardment that these planets suffered early in their origin created a lot of heat. Now, inside these planets, a lot of that energy wants to get out. And the way that they get out is volcanoes. So as a body cools, the volcanic activity will become less and less.
Like Mars, most objects gradually lose their volcanism as they cool. But not all. Io, a moon orbiting Jupiter. It's the most volcanically active object in the entire solar system. Hundreds of volcanic vents blister its surface. The vents shoot plumes of sulfur 190 miles into the sky. A single volcanic vent on Io creates a giant umbrella of debris, like nothing seen on Earth. Io doesn't cool like Mars or Earth because it has an extra heat source. Its huge cosmic neighbor, Jupiter, keeps it hot.
When you have a really big planet and you have a small moon orbiting close to it, like say Io near Jupiter, then what can happen is that you'll get tidal flexing of the moon. And just like you can take a wire hanger and bend it back and forth and it'll become hot, as you take that moon and you bend it and compress it because of Jupiter's strong gravity, what happens is that the interior becomes hot. And for that reason, Io still has abundant active volcanism.
Without a big planet nearby, Mars continues to cool. The dormant volcanoes are more likely to provide a shelter than a danger for humans. But before the first astronauts even set foot on Mars, they must conquer perhaps the biggest challenge of all: a dangerous 7-month journey through deep space. We've sent more than 40 robotic missions to explore Mars. Now, the dawn of human exploration on the Red Planet approaches.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow. And I expect to be around to see it.
We can get there. We've proven we can get things there and control them there and remain in communication and do great science and exploration. This is a place we should go to, and I think it is a place we will go to. I don't think there's any question. It's just a question of when that will happen.
But the trip of a lifetime will feel like a lifetime for the brave first astronauts. Mars sits almost 600 times further away from Earth than the Moon. 140 million miles farther than humans have ever traveled before. A one-way journey will take 7 months. A return, almost 2 years. Isolation will be a huge challenge.
We're not meant as people necessarily to be alone, right? You don't want people to feel isolated. It's not healthy, and even if you didn't care about it from a health perspective, it's not good from mission success. You want people to be productive in space, and in order to be productive, they generally need to be happy. It's a good thing, right? We're people.
The first astronauts to set foot on the Red Planet will live and work inside an Earth-made habitat. They face a deadly threat from cosmic rays, lack of oxygen, and Mars's violent dust storms. To survive, they must live inside this colony for a year or more.
So you're gonna have a small group of people, 3 to 5, say. They're gonna be encased in some metal shell on the order perhaps for as long as a year or two. How easy is this to get along with your best friend if they're in your face 24/7 for several years in a row? That's gonna be a real psychological challenge.
Scientists at NASA's Human Research Program investigate how astronauts will handle living in this confined environment. Lauren Levitin simulates the conditions of a typical Mars mission. she monitors its effects on these test astronauts.
We can deprive them of sleep, and we can look at their performance and stress them in that way and look at the team dynamics.
On a real Mars mission, a crew of 4 astronauts would share this space habitat for many months at a time.
These are unprecedented missions when it comes to their duration and their distance, and so we will be putting crews in habitats like this facility to make sure that the crew remains psychologically okay and that the team itself continues to function.
NASA will use intelligent computer systems to watch over their astronauts in deep space.
There are promising new technologies, and facial recognition is one of them that could track positive and negative behaviors from just reading your face.
A network of cameras observes the astronauts at all times to assess their psychological well-being.
The optical computer recognition is reading the faces of each of the crew members and the way the mouth moves and the eyes move. And we're testing it now to see what it can pick up in terms of stress and fatigue. They have to be prepared to do the work when they get to the planet, and they have to be in good shape on the trip home, too.
These astronauts will spend just 7 days in their space habitat. The longest a human has ever spent in space is 14 months. Living on Mars will be a colossal challenge. But for many scientists, not going to Mars is not an option.
The Earth was a wonderful cradle for life to get started, but the Earth will change. And in fact, in only a few hundreds of millions of years, the sun will turn the surface of the Earth into a desert. Our oceans will boil off, and life on the surface will cease to exist as we know it. Then we're going to have to venture to other places in the solar system. And probably the most attractive one is Mars. Mars is nearby. It's somewhat like the Earth geologically. And if our planet is being warmed up by the sun, well, so will Mars. Maybe water will melt. Maybe there'll be a chance to get more of an ecosystem started.
Mars will be a statement that we are capable of becoming an interplanetary species. It will be the first marker that we have that capacity. I don't see how we do it without going to Mars.
The wonder that we have for Mars today, our future generations are going to have, because we're still searching for life there on Mars, and there's still a lot to be learned about the planet.
Mars is a world of secrets just waiting for human explorers. A burning core that shakes the planet. Hidden reservoirs of water that may harbor life. An alien underworld of lava tubes and caves that offer shelter and resources. And dust storms that rage across the planet. This is the next stop on the human journey into deep space.